There must be something about Anker. They get probably the most requests for a video of anyone. I mean, they are one of the biggest, if not the biggest, power adapter maker on the market for USB devices. And today, I'm looking at the new GaNPrime 65, 120, and 150 watt power adapters. In this series, I try to answer the question, which power adapter do I want to get? The videos get technical, so hang on and always ask questions if you don't understand something. The performance is measured and compared to near competitors to see how each one stacks up. If you want to help out the channel, see the links on my webpage or down in the description. Patreon is now live, as well as the super button, thanks to my current patrons. The 3 power adapters come in new boxes for the first time. The white and blue boxes are gone. The GaNPrime marketing team is probably very proud, and I have to admit they do look more appealing. The packaging is very standard from Anker, with a plastic tray and a power adapter. There is a special bonus in the box though, something I've never seen before. I've heard complaints about power adapters not staying in the wall, so yep, now your power adapters come with a donut and some suction cups. Why isn't this on their pretty advertising campaign? I don't understand the naming scheme of 735, 737, and 747, so I'm going to go with watts. This wall plug thing can serve as the test bench. Let's plug it in, put in some USB cables, and see if the donut can hold. First test with all 3 ports, and nope, pulled it out of the wall. Okay, that was the first plug, so maybe it was a little stiff, so let's try again. And yes, it did stay in the wall this time. I repeated this a few times, and the angle matters a lot. If you try and pull the cables out with a little angle, which you shouldn't do, it pulls the plug out of the wall instead. This is a very tight outlet, so it's also providing a lot of the assistance. The donut does help solve the problem of keeping the power adapter in place with a lot of USB cables hanging off the back of the adapter. At least someone is trying. Depending on how you plug this in, it does look like the Anker thought about not blocking both outlets, at least with this smaller adapter. The 120 watt adapter is in a similar elongated form as the 65 watt adapters. All of these power adapters have the TUV safety listing for Canada, US, and the Japanese market. This also has the same ports, but obviously can deliver more power to those ports. The 150 watt adapter is a little larger, and this turns to the more conventional form factor for these power bricks. It does add an extra USB-C port though. No clear labels on any of the USB ports for what watts they can supply, and they are different in some cases. The one thing I don't like is the quality control of these, with the poor finish on the surface of the 150 watt adapters. I'm not sure what happened here, but it looks bad. The Anker user manual, as usual, has claims of the efficiency for each of the power adapters. This is a welcome plus. It will give us something to check later on. I think these numbers are low. The user manual does have a little statement about active shield for lowering the power level based on the temperature. This makes sense based on how hot these small adapters can get. As usual, the port sharing and power output claims are extremely confusing in the user manual. I guess no one RTFMs anyway, right? So I'll use a screen capture later to show this. The 65 watt power adapter packaging weighs 36 grams, and the power adapter weighs 150 grams, middle of the road. The 120 watt packaging weighs 95 grams, and the power adapter weighs 223 grams. This is not bad for this power level. The 150 watt power adapter packaging weighs 112 grams, and the power adapter weighs 269 grams. For 150 watts, this is very light and also quite compact. The 65 watt is the least interesting, but I found that it supplies 5, 9, 15 and 20 volt fixed voltage power delivery 3.0 modes. This also has an 11 volt PPS or a variable output voltage mode. I tested this mode and found that it can deliver the full 45 watts for Samsung fast charging. Here is a chart from the web that shows how this power adapter does port sharing. This power adapter does reset on all plug and unplug conditions, so it always renegotiates the power delivery. The 120 and 150 watt adapters share much of the same voltage conditions. Both have the same PPS and PD 3.0 voltage modes and can deliver the same power to the PPS port, 45 watts. The big advantage here is it can deliver the 45 watts to more than one port at once. Other power adapters haven't been able to do this in this class. The power adapter can also split the power 50-50, so 60 watts and 60 watts for the 120 and 75 and 75 watts for the 150. Not bad at all, and a leg up on some of the older designs. Something interesting is the claim in the user manual for these power adapters, which means they don't meet the DOE 6 efficiency level, yet they have the claim on the devices. This must be a worst case number and an upper estimate of worst case, because in testing I didn't get anywhere near these numbers. The 65 watt adapter came in at only 0.08 watts idle, and the 120 and 150 watt adapters were only 0.15 watts. Both of these meet the idle power requirement and exceed the manufacturer claim, and are actually quite good performers in this field. Let's talk about this 65 watt adapter. On light load, we can see it doesn't have the power factor correction, but once we take this power adapter up to full load, we can see it still doesn't. Not gonna get a 65 watt power adapter with power factor correction unless I make one. The power factor correction is a technique to consume AC power as efficiently as possible. The higher the power factor, the lower the comparable current, and therefore the lower the losses in wires and transformers that supply your power. The lines on the graph should all be the same shape. The power is always flowing, so rectified as shown. The 120 and 150 watt adapters behave a lot differently. These power adapters do have power factor correction, and the threshold for turning on the power factor correction is set much lower. Here you can see at 15 watts it is off, and then when switching to the 9 volt PD mode it turns on. Most devices now will use 9 volts to charge, which means you're getting the power factor correction advantage almost all the time. Even if the device switches back to 5 volts, this power factor mode stays active. Kudos to Anker for improving this significantly over the 100 watt design. Overload is testing when the device safely shuts down when too much power is drawn. It looks like the 65 watt power adapter will go to 73 watts, and it recovers after removal of the load. Not bad. The 120 and 150 watt adapters behaved the same and both tripped out at 105 watts. Both adapters recovered to the 5 volt condition after removal of the load. Let's look at some thermals. I'm only showing the 150 watt adapter here since most watts, most heat, and it didn't do bad. The high efficiency of this power adapter means it didn't throw out as much heat, which means the surface was only about 71 degrees Celsius. This is still hot, but it's acceptable. Again, we saw that if it gets too hot, the power adapter limits the output power. Okay, the bad news. The 120 and 150 watt devices did not stay within the basic requirements of the USB power delivery specification for DC output voltages. The voltage should stay within about 19.5 volts minimum, but these fell to 19.2 volts. The USB cable has some loss, but this is a best case cable, so you will likely only get 18.5 volts, which means to get 100 watts on one port, you're going to have to crank the current up a lot, which means it's going to cause even more voltage drop, which more current, and then an overload will happen. So getting to 100 watts with these is going to be pretty difficult for an actual real-world device. The 100 watt Anker power adapter also did this. No power adapters to rule them all. The 65 watt had plenty of juice in the 20 volt mode. 65 watts. Nope, skip this one. Skip all the 65 watt adapters. The AC line current distortion is bad, the power factor is bad, and it comes with a donut. The last part might be a positive. This 65 watt adapter is a new level of suck though. I'm being mean again. Relief. The 120 watt adapter soothes things over with some incredible efficiency, low idle power consumption, clean AC power consumption at all except the lowest power levels. And even there, sometimes it will be power factor corrected. I find this acceptable and a great way to keep idle power low and achieve higher output wattage when needed. This power adapter has a huge ability to put out watts in a small space. This adapter could use a bit of output voltage control. The price point is high, but not insane considering. Again, more relief. The 150 watt adapter is another breath of fresh air from Anker. This adapter is again solid performer, especially at the higher wattage outputs. This changes the form factor from the 120 watt adapter, but it does come with a donut. This steps the power level up without ramping the price up too bad. In comparison with other adapters, the 65 watt is the new worst performer. No idea why this one exists. Then, the 120 and 150 watt adapters are solid performers. These adapters sit in the top tiers with the Baseus and Hyphenex and do so with less idle power. No one adapter is perfect, of course, but this one is a good compromise. Safety listings across the board, which is always welcome. At least 2 out of 3 are a win. The 20 volt mode needs a bit of work, but it'll still do what it needs to most of the time. On the idle graph, the Ankers anchor the middle of the plot. They meet the idle requirements for the Department of Energy 6 idle requirement, which is nice to see on large power adapters. Really, no complaints here. On the average power consumption graph, the alternating current power quality of these devices takes a reasonably strong position as long as you aren't a 65 watt adapter. The 120 and 150 watt adapters sit up in the top of the list with the likes of the full-time power factor corrected models from Ugreen, Baseus, and Hyphenex. More power adapters. Must have more power adapters. The 65 watt is, by comparison to its larger siblings, not worth it. The price point is $60 and it lacks good AC power supply control. The 20 volt mode on this does work at least. The 120 watt adapter is a solid all-around adapter though. 20 volts is a little weak. The price point of $95 is expensive, but not out of line with other offerings. The high current PPS mode means you can fast charge multiple devices that use that mode no problem. The 150 watt adapter is great if you need a little more output power. It can do multiple devices at once while not getting too hot. Supporting those same high current PPS modes and bumping the price point up to $110 is actually starting to become a reasonable value if you need the watts. Overall, it looks like Anker didn't want to make the best 65 watt adapter, and no one else seems to want to either. There is no government requirement to make it better, so why bother? In this case, it looks like they were trying to make it worse. The other two are decent though. They all seem to have at least something holding them back, but are really on a much better power efficiency path. These really push the limits of what a power supply can do. 93% efficiency full load is something to be proud of. Also, they all come with the donut ring so you can keep them from falling off the wall. Final step, applying the stickers. Yep, they've been tested. I know the stickers can survive at least 70 degrees C now. 3 more boxes check. I need to make a new version of the sticker with the rating on it. Thanks for watching. Next week, the plan is to review these travel adapters. They have adjustable prong things so you can use the plug in nearly anywhere in the world. Neat. Oh yeah, check my website for upcoming videos. There's a schedule of release dates. I have many more of these adapters to get through, so many more videos in the future. Bye for now.